So we said if we have two lines, I'm just gonna I'm gonna do this bell work. You better have it all down, especially now. Better have all this down when I ask questions later. We're gonna come back to this later. If a line is sloping down from left to right, that's me as Ant-Man. No, hold on, look just like him. So if I am walking to the right, and I always start on the left and walk to the right on a graph, always, 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 just like you read left to right. If I am walking downhill, I'm getting lower, like I'm getting the height, my height above ground is getting lower. That's a negative slope. Shouldn't be real hard to remember. If going down left to right is negative. If it is hard to remember, then you got to put more time into remembering. Trying to give you some associations. Downhill to me is negative. Uphill to me means I'm getting higher. My height above ground is getting bigger as I go up, left to right. So that is a positive slope. If you just get that right, I actually just saw on the next district test, there's a question where just understanding that alone eliminates two of the answers. Just that. And then with the one more thing, I think you can just guess at the right answer. So now we said there's also a way to know or make a pretty good guess about what the it's not perfect, but there's also a way to make a pretty good guess about what the number part is. We said this, it's horrible. This is about a slope of one. That's each individual. All right. That should be down a little bit farther, like it should go right through the origin. It's a slope of one because the rise and run would be the same number. I go to the right one, up one, to the right one, up one. So it's a 45-degree angle, and it basically splits these quadrants right in through the middle. It bisects them. So if I know that's what a slope of one looks like, let's do this. That's a slope of one, that black. So if that's what a slope of one looks like, you don't know this, a horizontal or a flat line is a slope of zero. Anything that's flatter than this, like flatter means, more horizontal, more left and right, that's got to be a slope of less than one. It's going to be a fraction. It's a fraction that is, has a value of less than one. Anything steeper than that, because that's what slope tells you really, is how steep the line, we said. Anything steeper than that, like this is much steeper, the number part of the slope is going to be greater than one. So even if you can't make a guess at the actual number, if you just understand, well, it's got to be less than one. It's got to be greater than one. That will save you. It won't save you from making the mistake, but you'll catch the mistake after you make it because you're going to make mistakes when you calculate out slope. You're going to do a lot of them. There's a few steps. Then you're going to have to sometimes do it again for the perpendicular line. Or do it for another line. It may not be a perpendicular line. The number part to that would be less than one, maybe about 1/3. I'm just guessing. I don't even. There's no graph on it, so it might be 1/4, negative 1/3. It's smaller than one, though. I know that. That is definitely flatter than that line. This line is more up and down than that line, so it's got to be greater than one. Maybe it's 2, 3. I would doubt it would be 4. But even if you just know it's got to be greater than one. When you go through and do the slope, you calculate out the slope from the formula and everything, y2 subtract y1 divided by x2 subtract x1. The odds of you making a mistake that you don't catch by understanding this are pretty simple. Either the sign's going to be wrong or the number is going to be way off. When you do, if you make a mistake and it doesn't match up. It's doubtful you're going to make a mistake and it's still matched with the way the line looks. So just make sure you understand those two things, and it'll catch some errors that inevitably some of you are going to make. All right. So we did this last week. We're going to actually do it again, so I'm going to go pretty fast. If we know the slope of a line, So that's good. Come on, you know where you're sitting. Thank you. All right, so -2 is the slope of the original line. We said when we make a perpendicular slope, so we don't know what the slopes are yet. We want to create a perpendicular slope. And I'll talk about the rule in a minute. We said there's just a pretty simple process. Does anybody remember what it is? Or we're striking out on that process. Look back in your notes, find it. We did it at the end of class third Wednesday for you guys. It was example 4, might be in your books. If you have your books, I would look at example 4. If you can't find it, then that means you're not labeling stuff that you write down. You need to be able to find something that says how to create the perpendicular slope, or the perpendicular slope was like something about perpendicular slope. So turn to, you don't have a book? Not yet, but I'll look here. Okay. Yeah, but you need your book though. I've seen your book. Yeah, I don't know where to my book is. Well, come look for it. You need a book. I already did. Not there. No, I've seen your books. Because I can remember it, because I had to think, who in the world book is this? Because the handwriting was not great. That's what I can remember. And then again, I think you wrote your actual name on it. Yeah. So there's it could be underneath a chair. Sometimes they so try to find it. Again, we're going to do 2 examples. Well, 1 example from the book, and we already did that one. So, all right. So, what did you get? That's page 195. So again, I got some people. I don't even know what chapter. You didn't write this down since you got your books out. I assigned page 197. That's the starting page. 1 through 34. So write that also. Page 197, 1 through 34. That's what is every single problem in that is potential quiz question. And there's no IXLs really for this one. You need to practice the book problems. Still waiting. Andre, you found it. What do I do? Well, the slope is rise over run, but what do I do to make -2, the original slope, into a perpendicular slope? Get that. We're not graphing. No, we're not graphing. It's just a quick something you do to -2. Make it the perpendicular slope. It's actually 2 things, sort of. So I'm going to give you credit for that, even though I kind of started. But I feel like you knew what you're saying. That is a -2 as a fraction. Just remember, whenever you're dealing with slope, you're typically going to need it to be in a fraction if it's not already, if it's already a fraction and you have it. Because you're a lot of times going to be dealing with rise and run. And we need a rise number and a run number. That's how I make one number into a fraction. Just put it over 1. Now, as we said, to make it perpendicular, if that's the original slope, we flip the sign and we flip the numbers upside down. So that's the perpendicular slope of a line that we would then graph if we had more information for a graph. So really quickly, here's what we said the test was. I made you put a box around something in your book. If you multiply 2 slopes together, this is what we did last week. That's also on the quiz tomorrow. If you multiply 2 slopes together and you get -1, that means they're perpendicular. So as a final test, you may want to multiply them together and just make sure you get -1. -2, you don't really need to put -2 over 1 in your calculator, but -2 times, the way you would put this into a calculator is the number 1, then hit the ABC button, and then hit the number 2, and then just hit equals. So -2 times 1 ABC2 equals, and you'll see you get -1. You have to have a negative and a positive also. The only way you can get a negative number is with 1 negative and 1 positive. So just make sure you remember that too, and then you won't make some of the math mistakes kids sometimes make. So that's the perpendicular slope. Flip the sign and flip the fraction upside down. All right, show of hands. And I don't know how many people even did this, but I have a feeling it's not me. Raise your hand if you think it's A for the correct rule. What happens to your X value and your Y value if you reflect it over that? Raise your hand if you think it's A. B. C. D. E. Raise your hand if you actually did the process we did last week. Yeah, that's fine. Because nobody's right. I give you a process and then you don't follow it. That's what makes me mad. That's the phone call conversation I have. I say, hey, I gave them a process and none of them are following. They're not doing what I'm telling them to do. If you don't understand it, ask. Because again, I can't help if you don't ask. And we've done it like 4 times. We may have only done it once with this line, but we did it like over the y-axis, over the x-axis. We did it over x equals a number. I think we did it over y equals a number. And it's the same process every time, just a different line of reflection. So if that's my y, or the blue and the red are my x and my y-axis, that black line is the graph of y equals x. That's one of the 2 I said you have to memorize it. If you don't know how to graph it. If you know how to graph it, you don't have to memorize it, but you have to know how to graph this. And again, if that means memorize it, then memorize it. And you have to know how to graph x equals a number. What's x equals a number look like? And the only other one I said you got to know. What's x equals a number look like? David. Well, it wouldn't be 2 lines, it'd be 1 line. Well, again, you can't have perpendicular if it's just 1 line. I mean, unless you tell me perpendicular what. So if I just graphed x equals 2, what's that look like? Well, again, can't be parallel, it's just 1 line. It's actually the other way. Not horizontal. For up and down, I'm fine. You don't have to use the math words. Just describe what it looks like. X equals a number is straight up and down. You got to memorize that if you don't know. You've got to memorize this one if you don't know. This is the graph of y equals x. If you remember y equals x and x equals a number, you can probably figure all the other ones out. And when I say memorize them, I mean it's like you don't even have to pause to think about it. When I say it, that image pops in your head. When I say x equals a number, vertical line pops into your head. Shouldn't even have to think about it. Think about all the other ones, but those 2 you got to have down. So once I've created that, oh boy, I do a horrible job on, you do kind of need a graph paper when you're doing this reflection. I'm going to do my best to sort of so that's all we really need for what I'm about to do. So now, that is also not very good, but that's fine. So I always choose 2, 1, I said. So that's 2, 1. It gives me 2 different numbers, which I need, because one of the rules, the x and the y switch places. So if I choose 1, 1, I don't know if they switch places. It'll still be 1, 1. So I need 2 different numbers, and I'm trying to avoid negative. I might still get negative numbers if the sign flips when I do the reflection, but at least if I start with all positive numbers, I won't have negative numbers in both of them. So that is 2, 1. So the reason I'm picking a point is I said the rule is the same for every point on the graph. If I am reflecting a point over y equals x, it's always going to behave in the same way. It doesn't matter where it starts. It can't behave differently if it starts here than if it starts down here or here. Like whatever changes is always going to change in that way, no matter where I start. I might do two of them in this class since I'm recording. So if that's my original point, what do I do to reflect over the y equals x line? Z, what do I do when I'm doing the reflection part? What do I do? No matter where the point is, I go in what direction? It's not a left-right answer. I go. That would be up or down, left or right. It's not always horizontal, not always vertical. It's toward the, yeah, well, it's toward the line of reflection. Now that's pretty easy when the line of reflection is straight up and down or straight right and left, because then I just follow the grid lines. We said when it's diagonal, though, I can't. I mean, there is a way to follow grid lines. I showed you making a square. If you have a graph, though, it's not that big a deal to go diagonal. That would be one diagonal space on a graph. Like you'd see, I just went diagonally one square. Well, then if I kept going diagonally, that would be my reflection. You always go toward the line of reflection, straight at it. Pretty easy when the line of reflection is straight up and down or straight left and right. Not as easy when it's diagonal. So now, I just write the x and the y value for that point. The only reason I'm doing the graphing, like this is not really what I need. This is just to help me figure out the rule. So I started with 2, 1, and then that point went to 1, 2. That's really the only reason I did the graph. I just want to see how it changes. Because I was at the next question I asked, kids were looking at this graph. The graph that was just for me to figure this part out. Where does my point end up? And therefore, how did the x and the y change? So, Tommy, this was my original point. What happened? It just flipped, right? No signs flip. Like these were both positive. They're still both positive. So there shouldn't be a negative sign in any of the rules because I didn't flip the sign. A negative sign in front of the x or the y means the sign flips. Well, if you look at every single other answer, there's a negative. So it can't be that one. There's a negative there. Can't be that one. There's a negative there. Or it's way off. There's 2 negatives there. So it can't be that one. So the only one where there's no flip of the sign is this one. But we also said the x and the y flip, right? 2 was first. Now it's second. 1 was second. Now it's first. So they flip. Well, sure enough, the x and the y flipped in this answer. So again, if you can figure it out from like just having x's and y's and thinking about it, that's great. I'll tell you right now, not a lot of people can. I do this on this kind of graph. So use a number, or use really 2 numbers, an x and a y. Do the reflection with the numbers, like draw the line in, do the reflection, and then write your original point and then your final point and just see what happened to them. Did the x flip? Did the y flip? Like, do they flip signs? Did they change places? Sometimes the signs will change and they'll flip places on some of the rules. Like, all of these rules are possible. You just got to figure out which one it is by doing the actual reflection. Oh, we got to go faster. All right. So I'm going to go pretty fast through this one because we still have another one to do. This was like example 4. So page 195, example 4. It said, I want to create a line. And it was a big word. God, that is so bad. It was a word problem with like this picture. But if you notice behind the picture, it was really just a graph. And there was a line on the graph with 2 points on it. And they said, create a perpendicular line that goes through that point. So what do we have to do to create a perpendicular line? I don't know where I'm at. Jason, what do we do in the bell work to create a perpendicular line? Literally, I mean like seconds ago.
Oh,
Number two.
like create a.
Yeah, what did we do on number two?
So you gotta do rise over run, right?
So what did we do with them though? We created a fraction first,
Yeah.
which we,
Flip.
and then we do, it's called the opposite reciprocal. So I'm going to need to take the slope and I'm going to need to do that same process. But what's the problem? Like in this.
It's a negative.
We'll use that, but like I need to flip the slope. So what do I do? See a slope yet?
Yeah.
Do you? 'Cause I don't. We don't have a slope yet. We don't have it. So here's what I'm getting to. Sometimes they'll give you the slope, like I did in the bell work. I said -2 is the original slope. Sometimes they won't give you the slope. So what do you need to do? You need to find the slope. So use the formula. It's in your notes. It's on your reference sheet. It's the y2 subtract y1 divided by x2 subtract x1. Find the slope of that blue line. So if you were here, we did this last. For you guys, I think it was Wednesday, because we did the district test on Friday. So you're finding the slope of that blue line using the two ordered pairs that I gave you. If you don't remember, I'll sort of say we labeled them x1, y1, x2, y2. Then you just plug those values into the slope point. Everybody should be working on that right now. I see a lot of people just staring at the board. Find the slope. I'm going to kind of get, oh, my board is, actually, I'm going to write those, just write the points down separately since you don't have a graph, because I'm going to try to recalibrate my board. So for now, you just need to write this point, -2, -5, and then this point, 2, 1. And from those points, you don't need the graph to find, there is a way to find the slope without like doing all of this, but I haven't even shown you that. I mean, you can get it before. I'll let you. You've been engaged, so that's fine. I really want you to do this, so try to hurry back, at least to see me do it. So I'm gonna. Is anybody still writing the slope or I'm sorry, those 2 points? All right. So my board. It's about the 7th time I've done this now. So I'm gonna do it the same way I told you to do it. Do it much higher. Oh, actually, no, this. So if you are struggling on this stuff and I come by and you are not following this process, then you have nobody to blame yourself. This is exactly what you should be doing. And you got to start having a book in front of you, Troy. You're going to be in here, you're going to at least look like you're doing something. So if anybody walks in, they can't tell. Let's change this to blue. All right, so your first step would have been the step in red. You just rewrite the stuff somewhere like all nice and neat together. Take the points from the line. They may not give you a line. They may just give you the points and no line at all. That was the way the first example was that we did Wednesday. So this might be all they give you. There may not be a graph. Now from that, and again, make sure you write the formula down as well if you're struggling. Now you're just plugging in the values right where the formula is, like right above the y2, y1, right below the x2, x1. Just make sure you remember subtraction sign has to be in there, and the sign in front of the number is glued to the number. Can't forget about the sign. Actually, I'm going to call on something for this. I called on you or not, Becky. So, Becky, what is my top line going to be? Let's say y2 subtract y1. What's that going to be? Yeah, just find my values. If you label correctly, if you're nice and organized, you're doing that.
Oh, yeah.
Okay, I'll give you the bottom part. So say it again. So y2 is 1. So I just write 1. Subtract, make sure you put subtraction in, and then make sure you include the negative sign with that 5. The subtraction sign does not take the place of that negative sign. Both of them are in there. Kids do that all the time. So now, what is the bottom part then, David? So x2 is 2, subtract. You say it?
Yeah.
I thought you said the whole thing.
Yeah.
Yeah. I mean, you clearly seen the beginning. So now you have calculators, so do the math, and you get that. 1 subtract negative 5 is 6. Oh, subtracting a negative is a positive. Subtracting a negative is a positive. That's actually going to happen again in a second, but with variables, not with numbers. So just remember that. Subtracting a negative, and like we said, negative flips the sign. This negative sort of flips the sign of that. This flips the sign of that, so it becomes plus. Here's the other thing you have to remember to do in these. Make sure you simplify the fractions. It's most important on what we did last week. If you get two different slopes that look different, but really they're the same, if you simplify them, then the lines would be parallel. But if you don't simplify them, you may say, oh yeah, those aren't the same numbers, so they're not the same slope, when in reality they were. Like if you had these two slopes, you need to know that's the same as that. So make sure you simplify. The calculator does it for you. If you say 6ABC4, like you put a fraction in the calculator and just hit equals, it gives you 3/2. It'll do it for you. All right, now I need to know this is the slope of the blue line. So that's the slope of this line right here. But I need to create a perpendicular line. Daniel, how do I do that? What do I need to do to this value, the slope, to make the perpendicular slope? Good for the bell work number 2. So we're going to kind of flip it twice, right? If this is positive, I have to have a negative slope for the perpendicular slope, because ultimately the only way I can multiply them together and get -1 is if one is positive, which I have, and then one has to be negative, and then it would be flip the 3 and the 2. So this is the slope of the line I'm going to draw. I know the line I'm going to draw has to go through that point. Actually, let's change. So this is going to be the perpendicular line in there. So I'm going to go through 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So I'm going to go through that point right there. It's kind of like we normally, like if we have slope intercept form like y equals mx plus b, we start at the y-intercept. Like we start at a point on this line. Well, we start at that point because we know that point is going to be on the line we graph. This one, though, we know this point is going to be on the line we graph. So we're going to start at that point, and then we're going to use this rise and this run. So that's my rise and my run. I always put the negative sign with the top number. That means that I'm always going to the right first, because if my bottom number is always positive, I always start to the right. It just keeps it the same point. You can put it with either number. You can't put it with both, but I could say it's +2 over -3 or -2 over +3. Either way, when it comes to like doing the right, like having the rise and the run number. But you do have to put it with one of the two so you know which direction to go. So if I think of it as -2 on top, that means +3, I go 3 to the right. Negative 2 rise means I go down 2. And I think it's about there. Well, what's kind of the problem?
The gray thing.
Yeah, I went off the graph, right? I really don't want to go off the graph because that now I'm really guessing where it goes. So I told you this before, I'll just tell you real quick instead of asking. If you ever go off the grid, just reverse both directions. So instead of going right 3, I'm going to go left 3. Instead of going down 2, I'm going to go up 2. So 1, 2, 3, 1, 2. And if you'll notice, that's right in line with the other 2 points. If it doesn't line up with the other 2 points, like where you estimated, something's wrong. I mean, it should still look like a line. So that's how you create the line. All right, so unfortunately, I don't have a lot of time for questions on that. That is example 4. We already did one last week. There's a check problem you can try to do. Then there's a section of your practice problems that say example 4. I'll probably, and again, it's not a lot of prep time, but I mean, again, just go back and watch this problem. That's the best way to do it. Go back and watch. It's not super difficult. You just got to memorize the steps. Find the slope, create the perpendicular slope, and then just, whatever point they give you, use this rise and run to create your line. You watch that problem a couple times, then just pause the video and try to do it all on your own, then do the practice problems in the book. All right, so we got to get through this one real quick. Write this down. You have to memorize this. So it's a formula. I mean, you may remember it. Most of you probably don't. It's not one you use a lot. We use slope-intercept form most of the time. Y equals mx plus b. Most of you at least remember that one once you see it. This is one all this stuff is algebra. Everything we're doing is algebra. There's no geometry in anything we do today or really anything we do for a while. It's all algebra. I'm not even sure why it's the geometry left. We need to create or memorize, this is called point slope form. Not slope intercept, but point slope. We use this when we know the slope and they give us a point. That's why it's called point slope. So they gave us this point, and then in the equation, they give us the slope. Because that is y equals mx plus b there. So 3 would be the y-intercept for that equation. They want us to create a line parallel to that. Not perpendicular, but parallel. If they're parallel, Andres, what's got to be true if 2 lines are parallel?
Oh, when they meet, they have to meet. Oh,
Well, they won't meet.
perpendicular. That's
Yep.
parallel. And, they have the same slope, but
Same
different
slope.
intercepts.
Same slope is all we really, but it would be a different line, right? So I know I'm going to have the same slope. So there's the slope right there. So I already got part of my formula. It's just plugging in numbers into this. The y1 and x1 or x1 and y1, that comes from the point that they give you. So that comes from that. Now I'm just plugging numbers into that. So the only thing you got to do is memorize that. And now I just plug stuff in. Y is just y, just like we always have an x and a y when we say, y equals 2x. Well, right here, we have an x and a y right there. They just stay in the formula. So that's just going to be y. The y1 comes from the point. Make sure it's just like what we just did. Subtraction is part of the formula. Negative 3/4. And then subtraction is part of the formula, but my x1 is negative, so I have to write negative 3. Now here's where I said we're going to have that subtract a negative thing again. It's a lot easier if you just understand subtracting a negative means that's really x plus 3. So it's negative 3/4 times x plus 3. There's a way to do it if you don't change that, but it's so much easier if you remember that's what happens. Now I just need to multiply this times that and this times that. That's the distributive property. Again, just all algebra. All we're doing is algebra. So I still have y subtract 6 over here equals negative 3/4 x, which we needed because we know it needs to be parallel, so we need to have the same slope, which we do. And then in your calculator, if you do this, or if you just know how to do it, it's subtract 9/4. So the last step is if I want to get it into slope-intercept form, I just need to get y all by itself. That's what slope-intercept form is. So how do I get y all by itself in that? Where am I at? Well, how do I get y all by itself if I have this? Just get rid of 6. Y all by itself means I need to get rid of that negative 6, so I add 6. Good. So in your calculators, you may want to try this. Just make sure you know how to do it. The blue ones, you hit the negative first to put a negative number in. The white ones, you put the in first, 9ABC4, then you hit the negative button. So say negative 9/4 plus 6. And you should get, I think on both calculators, it looks the same if you put it in, right? That, and then I think that. You should get that. Or it'll, I don't know how it looks on the white thing. That's the way it should look on the blue calculator. So your answer, the line that is parallel but goes through negative 3, 6, and in slope-intercept form, y equals negative 3/4 x. At the very least, understand it has to have the same slope if it's parallel. That'll probably eliminate one of the answers, maybe even a couple of the answers. I looked at the district test, and just understanding that, I think, does eliminate on one of the questions 1 or 2 answers. Parallel lines have to have the same slope. Perpendicular, it would have to have the reciprocal. So again, if you remember that, that'll probably eliminate a couple multiple choice answers. And then it was plus, that's what this number is right here. Your calculator is saying 3 3/4. So that would have been the equation. So that is on your quiz tomorrow. So go back, watch this if you need to again, a couple of times, then try to do this one on your own. Then you can try to do the book problems. And then the proofs tomorrow come straight from HB9. If you just practice those enough, I'm telling you right now, you will see the exact same proofs that are on the quiz. I took the 3 most common ones. So you got to get to level 2 where you start having more than one blank. But I took the most common ones that appear over and over and over again. But you got to practice. Let's stop the video.